So here we don't know it is a parallelogram or anything else. It is a quadrilateral where AB equals CB, this line equals this line, and AB equals CD. Okay, so AB will be equal to CB equal to CD. Now they are equal, and G bisects EF bisects BD at G. So DG equal BG. Okay. So EF bisects BD at G. So DG equal BG. Okay. Now this one equal this one, and this sides are equal. So first we will take triangle ABG and triangle this one ABG. Okay. So we will join from A to C. Okay. Actually it will pass through this point, but we don't know. It will pass through this point or another point, we don't know. We will take the triangle ABG and BGC. Okay. So in these two triangles, AB equal BC. Given. Next BG is common side. Okay, this one common side to both these triangles. And then angle BAG equal angle BCG. This angle BAG equal angle BCG. Why? Because if we will take the triangle ABC, so ABC is a equilateral triangle. So these two sides will be same. Okay. So opposite sides opposite angles of equal sides of equilateral triangle. Okay. So now triangle ABG and BGC, these two are congruent. Okay. So these two triangles are congruent means this angle will be equal to this angle. Angle ABG is equal to angle CBG. So the congruent parts are congruent triangles are congruent. Now this angle CD and D. Angle CBG equal angle CBG. Okay. So if we will try triangle BCD, opposite angles of equal sides of equilateral triangle. Okay. If we take this triangle BCD, we know that BC and CD are equal. So these two angles will be same. Okay. So here ABG is equal to BGC. So ABG equal to CBG. This one. And CBG is equal to CDG. So angle ABG is equal to angle CDG. Okay. This angle is equal to this angle, but this angle is equal to this angle. So directly we can say this angle is equal to this angle. So ABG means this angle. We can also represent as FBG. Okay. And this angle CDG we can represent as EDG. Okay. So now this point may be different than this point. Okay. These 2 points may be different, but we have to prove that these 2 points are same. Okay. Here. So for that we have to prove that this is a parallelogram. Okay. If this is a parallelogram, then both the diagonals will bisect each other. So how to prove this is a parallelogram? So we have to prove this is a parallelogram. If it is a parallelogram, then the diagonal will bisect each other. So we already proved that ABD, this angle equal to this angle. We already proved. So means AB parallel to CD. Okay. Yes. Angle ABD equal angle CDD. Okay. ABD equals CDB. So these two lines are parallel. We have to prove that these two lines are parallel. How? If this angle will be equal to this angle, then we can prove that these two lines are parallel. Not this angle, sorry. This angle is equal to this angle is equal to this angle. Then you can say these two lines are parallel and it is a transversal. AB and BC. Okay. And this is the transversal. AC. So this angle DAC should be equal to ACB. Okay. So for this AG equal to BG, we have already proved. We will take these two triangles AGD equal CGD. Triangle CGD. So in triangle AGD and in triangle CGB, we know AG equal CG. Okay. Simplicity we call AGB is congruent to AGB is congruent to CGB. We already proved this one. So AG equal CG. Now GD equal BG. GD, this one equal this one. Or GD equal GB. How? It is given. No, this is the midpoint. This is the midpoint. Already given, na? In question. And these two angles DGA equal DGA BGC. DGA, this angle equal this angle. Why? Opposite angles. If two lines will intersect each other, then the opposite angles are same. Okay. So this side equal this side equal this side, and these two angles are same. So these two triangles are congruent. Therefore, triangle ACD is congruent to triangle CGB. So angle DAC is equal angle DCB. Congruent parts of congruent triangle are congruent. So if these two are equal, so this side will be parallel to this side. So AD is parallel to CB. BC. Okay. AD is parallel to BC and AB is parallel to DC. We already proved. And AB equal CD and AB equal BC. So this is a what type of quadrilateral? Quadrilateral. Rhombus. This side will be equal to this side, and this side will be equal to this side. And three sides are same and opposite sides are parallel to each other. So it will be a rhombus. As all three sides are same, so this side also will be equal. Okay, if these two are parallel to each other, these two are parallel to each other, then these two sides will be same automatically. So this is a rhombus. And we know the diagonals bisect each other of a rhombus. So this diagonal will also pass through G. So G is the midpoint of BD. Means this point, not another point. Okay, previously we don't know. This diagonal will cross to this point or not. But now we know, we prove. Okay, clear? So FBG, equal PDG. This angle equal this angle. Okay. Now in triangle, FGB and EGB. FGB and triangle EGB. Okay, FGB and EGB. In these two triangles, we know that this angle equal this angle. We already proved. And these two are opposite angles. Okay. And this side equal this side. Given. In question it is given. That is bisect. EF bisects at the point D. So DG equal BC. So these two triangles will be congruent by ASA. Two angles and included side. Okay. These two angles are same and included side is same. So these two will be congruent. If these two will be congruent, then EG will be equal to FC. Congruent parts of congruent triangle. Okay. In between, we left one thing that we have to prove that this point